In this video, we're going to create projectile motion tables that includes position and velocity. We're going to go ahead and start with a really tall cliff here, and we've got a ball that we're going to launch horizontally. It's going to go this way with the initial velocity of 15 meters per second. Okay, so 1 second later it'll be here, 2 seconds it'll be here, 3 seconds will be here, and 4 seconds will be there. Now we know horizontally that the velocity is constant, so I'm going to draw arrows that have the same length, and vertically the velocity is increasing, so my arrows are getting longer and longer and longer. So now I'm going to create my table. The first column will be for the time, which is measured in seconds. The second column will be for the horizontal velocity, and this is measured in meters per second. And then my third column is my vertical velocity, which is measured in meters per second. Okay, we're going to look at 0, 1, 2, 3, and 4. So this is 0, this is at 1 second, 2 second, 3 second, and 4 second. Okay. So in projectile motion, the only force acting on the object is gravity, and so there's no acceleration. So horizontally, it's moving at constant velocity. So which means that the velocity is the same the entire trip. Okay. And then vertically, it is accelerating downward. And let me go ahead and indicate my positive direction. So my positive direction is going to be to the right is positive x, and then up is going to be my positive y. Now this is arbitrary. I could have made down positive for y, so it's arbitrary, but I'm going to make it up positive, which means that our velocities, because we're going in the down direction, these will be negative. Okay, so we're going to start with 0. And we know that the acceleration due to gravity is 9.8 meters per second squared. 9.8 meters per second squared. However, I'm going to use 10 just to help us to do this a little bit more quickly, just mentally do a little mental math a little bit more quickly here. So we have negative 10, negative 20. So here the velocity is negative. The negative, once again, is telling us the direction. So it's telling us it's in the opposite of the positive direction, which is down. Okay, so then at 3 seconds will be negative 30, at 4 seconds will be negative 40. So notice the pattern here, right? Notice the pattern with the time and the vertical velocity. Now let's take a look at the position of the projectile. So I'm going to recreate the cliff again. And we're once again going to launch this with the initial horizontal velocity of 15 meters per second. Okay, so 1 second later it'll be here, 2 second, 3 second, and 4 seconds. This time I'm going to label the time. So let's say this is 0 seconds. I'm just going to label this. This will be 1 second, 2 second, 3 second, 4 seconds. Okay. And now I'll create my table. Just like before, this first column will be for the time in seconds. Second column will be position, measured in meters in the horizontal position. Third column will be the vertical position, measured in meters. Okay, so we're looking at 0, 1, 2, 3, and 4 seconds. Okay, so we're looking at here, 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 and here. Okay, so horizontally, right? Horizontally, remember we're moving at constant velocity, and we're going at 15 meters per second. So we're starting at, we're going to say this is our 0 point here. We're going that way, and horizontally, 15 meters per second means every second it's going 15 meters. Every second it's going 15 meters. Okay, so 1 second it's going to travel 15 meters. Okay. 2 seconds it's going to go 30 meters. 3 seconds, 3 times 15 is 45. 4 seconds, 4 times 15, and we get 60. Okay, so what we mean by 15 meters per second is that every second it's going to travel 15 meters. And so you can just take the time multiplied by the velocity and then get the distance that it travels. And now vertically, we're going to have to do a little calculation here. Vertically, it is not moving at constant velocity. Vertically, it is accelerating. So we have an equation here, which is delta y equals VIT plus 1 over 2 AT squared. Okay, this is one of the kinematic equations. And initially, it's not moving up or down. Initially, it's just moving horizontally. So initially, this is going to be 0. So then we end up with delta y equals 1 over 2 AT squared. Now, A is just going to be 10. So that's just going to be 10. So I get 1 over 2 times 10. Okay, and it's going to be a negative because, like before, I'm making the right positive and I'm making up positive. Okay, now if I made down positive, this would be a positive 10. But because I made up positive, this is going to be a negative 10 times t squared. Okay, so just focusing on the left and the right part here. Okay, if we plug in these numbers, let's plug in 0. 0 squared is 0. 0 times anything is 0. So we're going to start off with 0. This will be 0 initial. Okay, so we're starting with 0. This is our 0 point here. And then at 1 second, okay, we plug in 1 here. 1 squared. Go ahead and do that. So this is going to be half times negative 5. Let me go ahead and just multiply that together right now. So just do that. And half times negative 10 is just negative 5, right? So we have negative 5t squared. So delta y. All right. So this makes it a little bit easier to think about. So if I plug in 1 squared is 1. 1 times negative 5 is negative 5. So this is going to be negative 5. Okay? How about 2 squared? 2 squared is 4. 4 times 5 is 20. It's going to be negative 20. Okay? How about 3? 3 squared is 9. 9 times 5 is 45. It's negative. So negative 45. All right. The next one, you may need a calculator, but 4 squared is 16. 16 times 5 is 80. There's a negative, so it's going to be negative 80.